So welcome guys to our channel Intro Mech, and here we discuss about basic mechanical engineering concepts. So guys, as you know that we have started our new series regarding different digital engineering tools that are very helpful for your designing. So when you design different machines, different mechanisms, you require some kind of, say, pneumatic or electric actuators or different kind of mechanisms and different type of parts. So you must know these parts, where to use these parts, how to use these parts. So here comes the need of the digital engineering tool, because you cannot do hand calculations all the time. Yes, definitely you have to do some hand calculations so that you can give the proper input to these softwares, because that is very important for these tools, because you have to give the inputs and according to that this tool generates some output. So today we will see the selection of shock absorbers, like how they are selected and many other things. So without wasting time, let's get started. So you have to put Festo online tools, and you can see the Festo industrial automation site. Just click on it and the window will open. Now here you could see at the page, you have to go to products and then you have different options. Just go on to digital engineering tools, and this is our home page of digital engineering tools. Now here you can see there are a lot of options available: factory automation, gripper selection, vacuum design, the pneumatic sizing, CAD configurator, and you can just scroll down and you can see lot of tools are available freely, and you just have to utilize these tools. So today we will see that how we can utilize this tool for, say, selection of shock absorbers. Now the shock absorbers are very important parameters when we design the machines. Now let's see how to select the shock absorbers. So just click on that, and here you could see the shock absorber sizing. Now this tool helps to find a perfect shock absorber based on your application requirement. So that is very important, that what is kind of movement you need a solution for, whether you have a vertical motion, horizontal motion, inclined motion, or rotary movement, in which scenario you want the uh, shock absorber. So first you should know that where you are going to fit the shock absorber. Now let's say vertical motion, then again in vertical motion there are different scenario. You can see first one is free falling mass, that the mass is directly falling on your shock absorber. Second one is downward moving mass with some driving force, that means the mass is moving but it has some driving force. That means, let's say, it is moving with the help of some motor or say actuator or any other thing. And then we have upward moving mass with some driving force. So you should know the application, that uh, in which application you are going to fit. So let's say first the free falling thing. Now here you could see the example of the application. The part is directly falling on your shock absorber, right? So we have to specify the application parameters. Let's say my moving mass is, let's say, 5 kg, neither drop height, then the start velocity. You have some start velocity, right? Then the cycles per hour. So here you could see the cycles per hour also, because that indicates the life of your shock absorber. So that is also very important parameter, that what is the cycle. That means what are the cycles of your machine. So here you could see different parameters. Now let's change some application parameter, because we don't have any say results. So we have given the start velocity and let's hit, then again it is not giving the thing. So let's increase the mass and let's have the start velocity, say we can have 1 meter per second. And then there are number of shock absorbers in parallel, that is also mentioned. So let's say we have two shock absorbers in parallel. So let's select 2 and hit the show result. Now we can have different solutions like solution 1, solution 2, and so many other solutions, and it shows that some filters are also there, like we have fixed stop. Now what is fixed stop? So we can also check out that we have four different solutions over here, right? Now what is fixed stop? You just have to click on the I button and it indicates what does it mean. So to stop the movement at the end, two principles are possible. So you could read out those things like with metallic fixed stop on metal housing, or without metallic fixed stop, the stop inside the shock absorber. So according to that you can select these things. Now these are some internal parameters, we don't have to worry much about that. Then the cushioning reaction there given, like how is the cushioning happening in your require your shock absorber. That means what is your requirement. There is a soft cushioning and there is a hard cushioning. What does it mean? The soft cushioning, you can read what is soft cushioning and then what is hard cushioning. So according to that you can select. Now when I select soft, now you can see there are only three options, the fourth option is not available. So according to that you can have say filters. Now here cushioning adjustment are given, and then cushioning technologies are given. We have hydraulic and we have mechanical shock absorbers. Now if I select only mechanical, then under this category we don't have any mechanical shock absorbers. We have to go for hydraulic shock absorbers that have some fluid inside that. The shock absorbers are totally like mechanical components. That means we don't have to give some auxiliary input to them. So let's select again hydraulic and we have these options available over here, right? Then you can read at the bottom side they have given some important thing. You have different solutions, and now this is the important. The specified technical data refers to room temperature. At higher temperature in the region of 80 degrees, the maximum mass and the cushioning range must be reduced by approximately 50%. So that is very important thing that you should know, that if the temperatures are very high, these shock absorbers may not work. You may have to go for some specialized shock absorber. So let's click on the shock absorber. Now here you could see you have technical data, you have PDF, you can see the technical data, you can read the data like size, what is the size, then what is the stroke, the cushioning is adjustable, the mounting positions, you can see the maximum impact speed, then the mode of operation, you can see single acting pushing. So the circuit is given over here. The all the other parameters, maximum energy, the reset force, the product weight it can take, the material of seals, and all those things is mentioned over here. Now this is the catalog of the shock absorber. You can just check it out, and that is very important. Even if the software is directly giving you the output, you can just always refer the catalogs, because those catalog will help you to see the different parameters. Now here you could see the mechanical shock absorber, the series, what is the series, the elastic rubber buffer it is, and the adjustable one, these are hydraulic shock absorbers with spring return. So there are different type of a shock absorber, like adjustable, then self adjustable, and you can see the principles like hydraulic and mechanical, and according to the ranges, their applications, these shock absorbers are divided. You can see the product range and many other things about these shock absorbers over here. So this is very important, like how you input your parameters, how you select the category, because dependent on your application, all these things will give the output, right? Now let's change the motion type, right? So let's have rotary movement. Now here you could see what are the different outputs. Again, there are four different scenario they have given, and the distances they have given. So all these parameters you have to feed, and then we have inclined motion. If the mass is moving say on inclined plane, then we have to select the shock absorber. Now let's check out for the inclined plane. Again, we have moving mass, then we have height, then start velocity, cycles per hour, and the important factor over here is the angle of inclination. Again, it will give the different options which are available for this category. So this is how on the basis of your application you can select the shock absorber. So this is very important tool, guys, and I hope you got some new information and you will use this tool. So This is it about the shock absorbers, guys, and in our upcoming video I will come up with some new digital engineering tool. So thank you for your patient listening. Thank you.